Okay. Everyone can hear me?
Yes, sir.
Yes.
Audible, sir.
Okay. So is this code familiar for everyone? I'll just start with a small example and then we'll move to the lecture. Is it fine for everyone?
Yes, sir.
Yeah. So what this code is doing here? What you will get? Any idea?
Sir, it will display as 10.
If
Sir.
Okay, it will display as 10. We can try that out.
So we are not able to display that percentage D or decimal or binary. We have conformed to
If
the
you
anyone.
are not, if you are not giving the identifier, then it will by default take as decimal. If you'll not give anything, then it will by default take as decimal. Okay. Let me give decimal as well. Is that fine now?
Yeah, yes, sir. I can understand. Yes, sir.
Okay, next. How many displays I'll get?
2 displays, sir.
What are the values?
10 and 20.
10 and 20.
Nice. Same thing. How many displays I'll get?
3 displays, sir. 10,
Okay.
20 and 30.
10, 20, and 30, correct. Okay, I got 10, 20, and 30. If I change one thing, I'll change it to BA. Now what is the value?
Ten, 20, and 20.
Okay. Anyone else have different answers?
But I feel we cannot say because we cannot use the blocked and non-blocking assignments at a time. A single block.
We cannot use
The 10,
or
20, 20, sir.
okay, 10, 20, 20, one answer. Okay. Any answer two I got as your simulation error, right? We cannot use.
It will not show any error, sir, but the unpredictable output may be unpredictable.
Unpredictable. Okay. What unpredictable? Any value it will print, right? What values it can print?
Out of 10, 20, and
Unpredictable
30.
means what?
Yes, sir.
Out of 10,
20. Yes, it can print anything.
Oh, what is the first display it will print? The very first display.
10.
Okay. It is not unpredictable. What about the second one?
20.
Okay. What about the third? You told
20.
unpredictable.
Third one
What is
isn't 20.
It's
sir.
21
Third
set.
isn't
So from
20.
21 to 29 set.
21 to 29.
29.
Okay.
Oh.
Values. Okay.
Yes, sir.
Okay. Am I doing any changes to the value of A that you are changing the value? Okay, let us discuss it later. Any third answer?
No, sir, it will not change. Actually, that is a non-blocking assignment that you're using, third one.
Exactly. The exercise, whole exercise of doing this point is why the heck we have these two operators in Verilog. You need to understand the language. You told that we cannot use it's what you say, it's suitable to not to use in the same procedural block, the blocking and non-blocking. We'll come to the later part. First, you have to understand the language. Why we have these two operators, right? First, you have to understand the difference between them. So I got these two answers. Any other answer we have in the whole, what you say?
Sir, 10, 20,
Anyone?
0, 1, 2, 3.
Uh, 0, 1, 2, 3. How many displays will get first of all? 10, 20. Let me make this more clear. D1 equals to D1 as in D1 A equals to D1 means display 1, D2 A equals to, right? D3A. Now you tell me the value of D1, D2 and D3. What is the value of D1?
Is it 3 times 30, sir?
3 times, sorry?
30, 30, 30.
We'll get 30, 30, 30.
Yes,
Is
sir.
that what you mean?
Because these are the blocking assignment. First, non-blocking assignment will assign the value 8, 30, and all every time the values of A will be become 30.
So you are saying that D1, D2, D3 will give me 30, 30, 30?
Yes, sir.
Okay. Any fourth answer we have?
D1 equal to X.
D1 equals to X, okay.
D2 equal to 20.
D2 equals to 20, okay.
D3.
What about D3?
Again, X.
Okay. Any fifth answer we have?
Sir, 10, 20, 20.
10, 20, 20 you have the answer 1. Okay. Any fifth answer other than this 4 answers?
Can we think this in terms of clock cycle?
Clock cycle will come later. Why we need in clock cycle? I am not talking about digital anymore. I am just here giving you a small example of a code. You need to understand the language. I need to understand that how much of a language you know. Right? Basic 3 displays, 3 assignments. What all are doing here?
So
Any
my
fifth
answer would be okay. My fifth. So D1 will be X.
Okay.
And then D2 and D3 would be 30.
30, 30. Okay. Fine. Only one answer is correct here, right? Any third and any sixth answer we have? Any sixth answer?
D1X, D2X, D3, 10 to 30, 29.
10 to 29. I am not getting 10 to 29. Means any value it can pick, or it will print 10 to 39. What?
Sir, one question on the agenda. So I hope the agenda was to discuss some difficult topics of Verilog and system Verilog, right?
It is difficult topic. Can't you see? People are struggling to explain this. Yeah.
I mean, students are just randomly picking any number, right?
Yes. The main agenda is to understand what is Verilog stratified event queue and why we have the 2 operators here, right? Can't we have a single operator? Why we have basically 2 operators? Can't we do the same thing for a single operator? Okay, let us move. If I'll run, I'll get 10, 20, and 20. Now, why is it so? 10, 20, and 20. If I do one thing, do you guys know about $strobe?
Yes, sir.
Yes, sir.
Okay. Now you tell me the order of print.
Also, the blocking assignment will be run first.
Yeah. Now you guys tell me the order.
Sir, 10, 20, and 30.
10, 20, 20, 30.
You tell me D1, S1, which one will print first?
Sir, D1, then D2, then S1.
Okay. D1.
D1 is 20, D2 is 30. No, no.
D1 is
D1
what?
is 10. Sorry. D1 is 10. D2 is 20.
Okay.
And
D2 is
S1 is 30.
20.
S1 is 30.
Get S1 is 30.
30, sir.
But what is an initial block? An initial block is a procedural assignment, right? So everything will go in procedure. So it should print the stroke first. Yes or no?
Yes, sir.
Yeah, should be, but dollar strobe execution reason is different.
So strobe will
Correct.
take into the default value, sir. So the first will be printed the S1, sir.
Okay. First, somebody is giving me answer is
First will be printed to
S1,
the
okay.
strobe value. That means strobe is an unknown value for default
the value?
value, sir. Unknown value,
X.
sir. X.
Okay. Next.
And next D1 is displaced to the 10, and D2 is displaced to the D2 is displaced 20.
20. Okay.
That's right.
The point one guy told about we have different regions. In Verilog, we have a concept known as Verilog Stratified Event Queue. Now, forget about this
That
answer.
means active
If I will
region.
run, yeah, yes.
Active region, blocking region, non-blocking region. That means like that, sir. You are saying?
Yes, I'll come to that. I'll come to that. Yes, I'll come to that. We'll arrange it. Now, if I run this,
okay, sir.
The one who told answer 1. Yeah, can you see? The one who told answer 1 is correct. We are getting strobe first. Now I'll show you one more thing. I'll comment this out, uncomment this, and give a delay here. What values I'll get? If I'll remove the delay, I'm getting 10, 20, 20. If I'll introduce the delay, what I'll get?
10, 20, 10.
10, 20, 10.
10, 20, 30.
10, 20, 30. Correct. We'll get 10, 20, 30. Now, you guys are very confused. Let us understand what is happening here. We got 10, 20, and 30. How someone is reaching it to this position, right? So in Verilog, every time unit, this is a timestamp. The simulation start from time 0 and end till whatever we want to finish the simulation. Start from time 0, it will move to time 1, time 2, time 3. Now, every time unit has 4 different regions. What are those? Somebody was saying that. What are those 4 regions?
Active, inactive, NBA,
Active,
and monitor.
Inactive, NBA,
And monitor.
and postponed. Now, the simulator will start like this. It will go to time 0 active, inactive, NBA, postponed. Again, move off. Time 1 active, inactive, and VA postpone. Again, move off. Active, inactive, NBA postpone. Like this, simulation will start. Timestamp. Every timestamp had 4 regions: active, inactive, NBA, and postpone. Now NBA and postpone, that we'll see. First of all, you tell me, did you guys understood this?
Yes, sir.
Right? Okay. Now, I believe I need to. Yes. Are you able to see this? We have 4 regions: active, inactive, NBA. Now we can jump from inactive to active, NBA to active, that we'll see later. And once you reach postpone, you cannot jump. You'll directly move to the next time step. Inactive, what happens? Blocking assignment is executed. What is blocking assignment? Is A equals to 10 a blocking assignment?
Yes, sir.
Blocking assignment means your evaluation and updation happens in the same time unit, in the same region. If I'll give A equals to 10 plus 20, 10 plus 30 will be evaluated in the active region as well as assigned in the active region. This is known as blocking assignment. Next, evaluation of RHS of NBA. Let's say we have A, B, A, C plus 1. Can you see what is the RHS of this expression? What is the RHS of this expression?
C plus 1.
C plus 1. Right hand side. Now the C plus 1, now C will have a value. Some value plus 1 will be evaluated. That will be stored in the active region. That will be stored here. Let's say in temp it is stored. For instance, I'm saying this is what happens in the active region for RHS. We'll come back to this. Next, we have dollar displays evaluated in active region as well as dollar right. You guys know about dollar right?
Yes, sir.
Okay, dollar right. Now evaluate inputs and outputs of the primitives, your AND gate, OR gates, basic gates, those primitives. So the inputs and outputs are evaluated in the active region. Next is has 0 assignment in inactive region. Clear this. Now here comes updation of LHS of will be assigned to this value, will be assigned in NBA region. So NBA is a 2-step process. One step is evaluation of RHS in the active region. Second is your updation in the NBA region. And last, you guys know dollar strobe and dollar monitor, right? Make sense?
Yes, sir.
Yes or no? Okay. Now, where did we go wrong here? Where did we go wrong here? We were giving some bunch of different answers. Now, based on our learning, let us do some simple exercise. So let me do one thing. Active, inactive. Are you able to see the screen?
Yes.
Yes, sir.
Okay. Fine. I'm not able to copy this. Okay. Fine. Now, our simulation will start like this. Active, inactive, NBA, postpone, active, inactive, NBA, postpone. timestamp 0, timestamp 1. Now, do you guys know about Legos? We'll fill this Legos. Think this as a Legos and we'll fill here. First of all, we'll go with module. What is the value of A? Before simulation, what is the value of A?
X.
X. Okay. So we'll fill here the value of A equals to X. Next. How many procedural blocks we have? We have 1 procedural blocks. So this all will be executed in time 0. And inside procedural blocks, all will go in step by step. First, what will you evaluate? A equals to 10. In what timestamp this line number 9 will be evaluated? This line
Time
number
0
9.
active region.
Time 0 active region, correct. Okay. 10. Next, line number 10. Dollar display.
Time 0 active region.
Time 0 active region. Okay. Dollar disk. Okay. Let me give D1. Next, A equals to 20.
Same.
Okay. Next, line number 12.
Same.
Okay, fine. Now, what about the line number 13?
NBA regions.
Okay, expression 30 is evaluated here, and the assignment happens in the NBA region. What about 14?
Active region, time 0.
Active. Still my simulation is not working. Okay. D3. This should be D2, right? Okay. Do you have anything else to be filled up in this spreadsheet?
No.
Okay. Now we'll start our simulation. How will start? We'll start like this. I've told you we'll start, first we'll execute all the active region. So what is the first? The value of A is updated to 10 from X. What value this D1 will display? What value this D1 will display? 10.
10, sir.
Next, okay, the value of A is updated to 20. What this display will print?
20.
Okay, now I'm displaying the value of A. What is the value of A in this region?
20.
20. That's why we were getting, let me run it once again. That is the reason we were getting 10, 20, 20. Can you see? Got 10, 20, 20? Now, let us comment this. Okay, leave it. Let us introduce strobe. S1. A. We'll do the same exercise. Okay, first line. Where this line number 8 will be?
Postpone.
Postpone region. Do I have to change anything or everything is fine? Yes or no? Okay. If I'll run, I'll get a display as first display.
10.
D1 equals to 10. I'll get second display
20.
20. Third display
20.
20. Do I have anything to be executed in active region of time 0? No. I'll move to inactive. Do I have anything else to be executed in active region of time 0?
No.
No. Do I have anything else to be executed in time 0 NBA? Yes. The value of A is updated to 30.
30.
I'll move to postpone. What is this postpone? S1. What value it will pick? From the previous
30.
time slot, what is the updated value? 30. That is the reason you're getting this. Okay, let me run. I'll show you. Are you able to see? Are you getting the same value? Yes or no?
Yes, sir.
Make sense? We'll do one thing. #1. Okay. What I need to change? Do I need to change this strobe? Do I need to change this strobe? No.
No.
Do I need to change this? This,
No.
this? No. Okay. Now #1. #1 means full stop. I need to remove this one. #1 means full stop. Do you have anything else to be executed in time 0?
No.
No. So we'll move to time 1. Time 1, this will unblock and move to the next line. What is this $display? Where it will be placed?
In active region at 1 nanoseconds.
Active region in 1 nanosecond. D3. Now let us start the simulation from here. What is the value? I'll get
10. D1 10. D2 20.
D2 20. Strobe
30. 30.
Strobe 130. D3
Again 30.
30. Let us run it. See? Are you getting the same value as you have calculated? Yes?
Yes, sir.
Are you guys up for a challenge?
Yes.
Yes, sir.
Okay. So do you want a challenge in this topic or in some other else?
Some other.
Okay, fine.
So before we move on to some other topic, I have some questions in the same topic.
Right. Right. Go ahead, please.
Okay.
Go ahead, please.
So over here we discussed about the display part, but Verilog we are making a hardware, and by non-blocking we are making combination, and by blocking we are making a flip-flop.
Correct.
Right. So in the first question, when we did A equal to 0 and display the A, and then A equal to 20 and then display A, so these two were in the same time, right? Like in the same clock cycle.
You
So
forget about
wouldn't
the
there
clock
be
cycle for now. You're talking about this
contradiction?
one. See, forget about the hardware now. First understand the language.
Okay, but if we make a hardware out of this, like, wouldn't there be a contradiction between the 10 and the 20?
First, you have to understand why we have these two operators. Second, where we use this. And now, whenever you model flop, whenever you sample it, the old value will be sampled or the new value will be sampled. Let's say I have 3 flops. Okay.
Okay.
And one is present here. I am giving clock, synchronous clock to everyone. This is my D, Q1, Q2, Q3. Okay.
Okay.
Fine. This is my clock. This is my D, somewhere it's 1 D, is CLK. Now what will be Q1? What will be Q2? What will be Q3?
The same value, each cycle delayed.
You tell me in waveforms. First of all, it's a simple example, simple D flip-flop. Now you tell me the value of Q. This is 5. Okay. 15.
Okay.
25. 35. Okay. Since this is a flop, so and this is synchronous, at 5, what will be the value of Q1?
1.
1. Okay.
Yeah.
Value of Q1 will be 1 until
the D is 1.
15 1. Okay. Okay, fine. What is the value of Q2?
At 5,
Let's
it will
say
be 0.
the all values are reset to 0 for now. You tell me what is the value of Q2B at 5?
Q2 at 5 is 0, and then it in 15 it
What
comes up
value it
as
is sampling? Yes, you're correct. What value it is sampling? You're sampling the old value. Now you tell me what is the value of Q1 here, 0 or 1? If you zoom in here, what is the value at 5? What is the value of Q1? Either 0 or 1 or in between, or 7.5 or 2.5. What is the value? Getting my point?
It's not stable. Yeah. Yeah.
What is the value of Q1?
At that instant itself, can't say, because if that instant itself it's changing, right? So
yes,
it's
what
not
value Q2 will sample? Will it sample 1 or will it sample 0 at this time?
It will sample 0.
It will sample 0, correct.
Yeah.
At the next instant, it will sample this one. Perfect.
Yes.
Now you understood. You are sampling the old value. This is the old value and this one is the new value.
Yep.
0 is the value, 1 is the new value. So for a proper hardware to behave as a flop, old value should be sampled. Now to model this old value, we have to use NBA. If you use BA, everything will be changing in the active region. That's why we are suppressing the write later. First, we are reading the value. Here, if you see the NBA portion, the RHS is executed here. So when everyone will sample the value, it will sample from the active region, the old value. What is the new value of A? If I am doing A equals to B plus 1, right? NBA B plus 1. B is some kind of any value. B plus 1 will be evaluated here. Now, if some other parallel blocks is accessing this active region, means this A, what value it will sample? B plus 1 value or the older value? The older value. So to behave it as a hardware, to behave the language as a hardware, we are going for this two operators. Make sense? Why we have two operators? This is the reason we have two operators. Without a single operator, we cannot do it. We cannot mimic our code to behave as a flop. See, in synthesis, it will work. In simulation, it will create an issue. If you write a flop, like always at the rate, and if you write B, your Q equals to D, this will work, not an issue. In synthesis, in simulation, I have to use NBA. We'll discuss this later. First of all, you understood the gist of it?
Yes.
Any doubt you have?
No.
Okay, fine.
Thank you.
So the next challenge, okay, it will be interesting. A equals to 10. Others, do you have anything to ask? Tell me the value of A.
Sir, it will throw error.
Okay. One answer. What error? How many types of error we have? Do you know the answer? How
So
many types of error we have?
depending on the simulator, it can give 10 or 20.
Correct. Depending on the simulator, it can give 10 or 20. Okay, but can you prove? We have how many simulators we have? 1, 2, 3, 4, 4 commercial simulators we have. Can you prove it?
Yeah,
Can you try?
logic behind that is
Sir,
two initial.
Yeah, please. Anyone?
Sir,
Logic
it
behind
will
that?
be
What you're saying?
executed. So 20 will be answer, sir, because
Okay.
initial will be executed at 0th simulation, and final third simulation will be executed to the display second 2 nanoseconds. That will be the current value of the value is 20, sir. It means.
Okay.
But
We'll
instant
discuss
time
that
A
20.
value will be 20.
Sir, initial blocks
Not correct.
will be executed parallelly. So simulator
Correct.
does not guarantee any initial block, like priority to any initial block. So it can be 20 or 10.
Correct. Up till this, it's fine. The pace and all, you're following.
Yes, sir.
Hello. Okay. So the correct answer pointed by the guy, I'm sorry, I cannot see your names. I'm using the web browser. So it depends on the simulator, what it will pick. Now somebody was saying 20. Let us go with this exercise. We have learned Verilog, this one. Okay. First of all, you tell me how many initial blocks we have?
3.
3, correct. What is the variable we have? What is the value we'll have?
A initially has X.
Initially we'll have X. This is fine. So this is thread 1, thread 2, thread 3. Which one will run first?
Let's assume T1.
Let's assume T1. One scenario we cannot guarantee. First scenario, T1. A equals to 10. Now, do we have A equals to 1 is complete? Do you have anything else to be executed in time 0? Do we have anything else to be executed in time 0?
For this
Yes,
thread, no.
what it is? For this, I'm not talking about thread. I'm talking about the timestamp.
Okay,
do you
then
have anything else to be executed in time 0?
T2.
T2. T2 we have. What is the value?
20.
A equals to 20. Okay. Now, third thread, #2. So I'll move to #2. Which reason? $display?
Active.
Active. So $display. So what value I'll get for this
20.
scenario? 20. Correct. We get 20. We took T1 first. Now, second scenario. Scenario number 2. Okay. T1, T2, T3. We'll start with T2 first. T2, what is the value?
20.
20. Do we have anything else to be executed in time 0?
T1.
T1, A equals to 10.
10.
What value $display I'll have?
10.
10. So this is known as typically write race. You are writing onto the same variable. It depends on the simulator. Now you'll say, sir, how can you say that? Right? Let us try LDEC Rivera Pro. what I got? Okay, 20. Cadence. About 20. Okay. Am I lying? Let me see. Again 20. Okay. Synopsis, last chance. Oh man, 20. Okay. Somebody was saying that it's a simulator dependent, but I'm getting 20. Is it correct?
Yeah, it is correct.
But why I'm getting 20 every time? Any newbie can go fire up EDA and he will get 20 every time. If I will put this 20 here, this 10 here, and if I will run, I will get 10 every time. Now, how to prove if it is the right rate? I'll do a small trick. Okay. Just let us do a trick. Can I put it outside? Will there be any harm if I'm putting it outside? Outside the scope of test? No harm, right? I'm still getting his 10. Okay. Now let us do one thing. Module sub module. I will cut it. I will paste it. Can I do like this? Can I call a module like this? I'm calling a module sub. What's S? How many threads we have in entire code? Same thing, no? Yes or no?
Yes.
Okay. Let us start. LDEC. We'll see LDEC first. Let me see what LDEC gives. Okay. What LDEC is giving?
20.
20. Fine. Next. Cadence. Okay. Cadence is giving me 10. Nice. Okay. Let us go to mentor. Same code. I'm doing nothing. Okay. So mentor and cadence are some brother, sister or something. They're giving the same values. Okay. Let us go to synopsis. Synopsis is VCS. What I'm getting? 20. Now, can you say, is it a race? It is depending on the simulator. Now, you have to understand how I have bent the simulator according to my own need. It's known as the same thing. This is known as typical right race. Okay. If I do like this, $display A, this is known as read write race. Fine. Either you'll get the default values A or you'll get the 20. Depends on the simulator. You guys understood? Any doubts you have? Somebody speaking? You can mute them. Yeah. Others, do you have any doubt here? Did you guys understood? Am I audible?
Yes, sir.
Do you have anything to ask here?
Sir.
Yes.
So we'll give to the another module and sub module. So you called it to the module. The main
Call
module.
that mod. I'm just bending the simulator according to my own need in order to give you some taste of simulator race. I did nothing. It is only this what you say, 3 initial blocks, nothing else. You don't go deep there. You just understand the process, right?
Okay, we have to give to the 3 initial blocks in the parallelly. So the execution will be depends on the simulator.
Correct. So
right, sir.
let me give you some
But
different
it
thing
will
as well.
be this code will be given to the all times in the 10.
Yes. Okay. What output I'll get? I'll not tell you the answer. This is your homework. What output I'll get?
It means error, sir.
Yes, it will be error. Let me change it. Now it won't be error. Fine. Okay.
Yes, sir.
Tell me.
The answer will be 1110, sir.
1110. Okay. First answer I'm getting 1110. Any other answer I have? Any other answer I have? Am I audible, guys? Yes, no, don't know. Yes?
Yes, sir, you are audible, sir.
Yeah. So let me simulate it. You'll basically get 1x10. What is happening, we'll see in the next session. Okay. See, it's 1x10. If you want to explore more, you can go for the strength resolution, a concept known as strength resolution. You can search that out. Okay. So I'm done for the day.
Sir,
If
but
you
it
have
was
anything,
scheduled for 7:30 to 9, right?
I am really sorry I came late. It was scheduled to 7 or something. I forgot. I was stuck in your traffic.
Okay, so only these two topics were planned for this session?
Yes.
Okay.
Hi, sir. Like before
For the rest sessions, you have to like enroll for the courses actually. So actually, this was a demo classes only. So there will be more session obviously. For the that sessions, you have to enroll for the courses. There are RTL courses and verification courses with the placement oriented courses and the product based company. So just go through our website was www.vlsiforall.com. Check the courses whichever you want to interested in, like check the things first.
Yeah, but actually, sir, I was going through the agenda, right? The event
Yeah,
agenda. It was mentioned.
actually we can give the demo classes for 1 hour only, right? Obviously, there are many topics, like 90 topics are there. We can't give 90 hours classes free of cost, right?
That is right,
That
sir.
is the only
Okay.
thing. You can go through the courses, and courses are very, you can check the syllabus first. You will get the idea.
Okay.
So anyone have any doubt, any query?
Yeah, I had a doubt. So in that example which you gave for multiple initial evaluations, is it more dependent on the like the condition, like the race condition itself, or is it dependent on what the simulator wants to like pick for that value? So
It is
inherently, is
typically
it
race
like
condition. It is a race condition.
race condition?
It
So it
depends.
doesn't. So
yes.
So let's say we run it
Go
again
ahead.
and again for the same simulator. We try to run it again, so we can expect different values. Is it?
It depends. We don't know under the hood what simulator is doing. It is picking either the submodule first or either the first your assignment or the last assignment. It depends on the simulator. We don't know how different vendors are using, or different vendors are using their own tactics to do it. It is generally a simulator race. How they are handled, we are not here to discuss, because those will be your application engineers and they will do that.
Okay.
It is not in. It is not in the language. Language says that if it is what you say, if you are doing evaluating or assigning some values on the same timestamp on the same region, it will be a race.
It's just
Language
it's
is saying
typically
that.
a race. Okay. Okay.
Yes, it's typically a
Understood.
race. It can pick 10 or it can pick 20.
Okay. Understood. Thank you.
Okay.
Anyone else? Any queries? Any doubt? So, any like any courses and or anything. So, anyone want to give the feedback about sir?
Yeah, you can give the feedback like how was the session? It
Yeah,
was okay.
yeah.
It was good.
So
I got
what
one
we should
feedback
be
that it
next
was very
session?
less. Yeah.
Yeah, exactly.
Very less contents. I'm really sorry. Actually, I was packed. I was stuck in your traffic. That's why I also messaged your Rajit that
If you
I'll
can give the
be
feedback,
delayed
we
by
can have
5 to 10.
much more sessions on the next weekends also. So if you don't show your interest, then we obviously not have the sessions for 1 month. Everyone, we have only one demo classes. So
No,
depending
definitely,
on
it
the
was a good
feedback.
session. Yeah, it's a good session. Thank you. Like it did. I think these are more interview. What interview would be asking. So it definitely helps us create a thinking in that manner. So yeah, it's a good session. Thank you.
Yeah, so it was a good session. But I was expecting
That is different
month.
courses are there.
Okay, understood.
So should we are ending the shooting? If anyone have any doubt, you can contact us. Okay, thank you so much, sir. Thank you, everyone. Thank you. Bye.
Yeah, thanks for everyone joining. It's about 50 plus students I saw the first link. Anyways, it was lovely talking with you guys and an interactive session. I just like interactive sessions with the students. So I'm ready for that short span of time. But yeah, it was really amazing with you guys. Okay, then we'll see next week if how many you guys join. Okay, then bye bye.
Bye, sir.
Madhav, you can end the meeting.
Yes, sir.